Now next topic, that is elastic collision in two dimensions. Consider two masses m1 and m2. Mass m1 is moving with initial velocity v1I and mass m2 that is at rest. And now mass m1 collide with mass m2, and after collision, suppose the velocity of mass m1 is v1f and of mass m2 that is v2f, and both masses are moving in the directions making an angle theta 1 and theta 2 with respect to x-axis as shown in the figure. Clear? Now here we have to find the velocities of these masses after collision as well as the directions of these masses after collision. Okay? Now this one is elastic collision. In any type of collision, linear momentum always conserves. So according to law of conservation of momentum, we can write initial total linear momentum, that is m1 vector v1I, here v2I that is 0, so no need to write momentum of mass m2, that is equal to after collision the momentas of each one, that is m1 vector v1f plus m2 vector v2f. Now take two components of this equation. So take components in x direction as well as in y direction. So if we take components in x direction, then here m1 v1I that is in x direction, so x component is there, y that will be 0. Then for m1 v1f, x component will be m1 v1f cos theta 1, and for m2 v2f the x component is m2 v2f cos theta 2. Similarly, we can take y components here. So y component for m1 v1I, it is on x axis, so y component is 0. For m1 v1f, y component here, that is m1 v1f sin theta 1. For m2 v2f, the y component that is here on negative y-axis, so we can write minus m2 v2f sin theta 2, right? Now for elastic collision, kinetic energy also conserves, so we can write here as per conservation of kinetic energy, initial that is half m1 v1I square equal to final that is half m1 v1f square plus half m2 v2f square. Now see here, three quantities are known. Mass m1 is known, mass m2 is known, and v1I that is known one. After collision, there are four unknown quantities: v1f, v2f, theta 1 and theta 2. But here in theory, we have only 1, 2 and 3 equations. So with the help of 3 equations, we can find only 3 unknown physical quantities. But here we want to find v1f, v2f, theta 1, theta 2. Clear? So here we have to find any one physical quantity by experiment, or experimentally we have to find any one physical quantity. So out of these 4, we have to find any one physical quantity experimentally. Then after, from this equation number 2, 3 and 4, we can use the elimination method and we can calculate the remaining 3 unknown quantities. Clear to all of you?